groundbreaking discovery by capturing the first ever real image before the Big Bang. The James Webb Space Telescope, or JWST, has recently accomplished a remarkable feat by taking the first ever real image from before the Big Bang. This achievement marks a significant milestone in the field of astronomy, as it marks the first time such a discovery has been made. This important new development has the potential to call into question long-held theories about the beginning and development of the universe. According to the Big Bang theory, which is generally accepted within the scientific community, the origin of the universe is postulated to have been a point of matter and energy that was extremely hot and dense. After that, it rapidly expanded and cooled down, which led to the formation of galaxies, stars, and other heavenly structures like nebulae and clusters. The most recent findings from the JWST, on the other hand, have investigated what took place before this monumental event, which has sparked new questions and possibilities in our understanding of the universe. Researchers in the scientific community have put forward a number of hypotheses that could account for the events that took place before the Big Bang. These theories include the concept of the Big Bounce, which suggests that our universe is part of a cyclical process in which a previous universe collapsed into a singularity and then rebounded into a new one. In this theory, our universe is part of the cycle. The ekpyrotic scenario is an alternative explanation for how our universe came into existence. This theory proposes that our universe was formed as a result of the collision of two higher dimensional objects known as branes, which led to the phenomenon known as inflation. In addition, the scenario that takes place before the Big Bang proposes that the universe underwent a transition from a state in which it had low energy and high curvature to one in which it had high energy and low curvature. This transition took place during a time of superinflation and involved the transformation of quantum fluctuations into seeds that shaped the structure of the universe. The most recent finding that the JWST has made is that it has identified the earliest proto-galaxy cluster that has ever been seen. This event took place approximately 650 million years after the Big Bang. This discovery sheds light on the hierarchical development of the universe by demonstrating how cosmic structures evolve from smaller fluctuations in density to the formation of galaxies, groups, and clusters. Specifically, this finding demonstrates how cosmic structures evolve from smaller fluctuations in density to the formation of groups and clusters. Scientists are able to gain insights into the formation and development of galaxies throughout the history of the universe by studying these early clumps of matter and the interactions that occurred between them. Previous ideas about how galaxies are born and developed have been overturned by the observations made by the JWST. Because the galaxies found in this groundbreaking image are both unexpectedly large and massive, astronomers have been forced to reevaluate their understanding of the origins of galaxies. This image was taken by the Sloan Digital Sky Survey. As a result of this discovery, it appears that the population of massive stars that existed during that period in the history of the universe may have been up to 100 times larger than what was previously estimated. The Big Bang Theory explains the universe's origin. Most scientists agree that the Big Bang Theory is a good way to explain how the universe began. This theory says that the universe began as a very hot and dense point. This point is often called a singularity. This one point had all the matter and energy that would eventually make up the whole universe. About 13.8 billion years ago, something very interesting happened. The Big Bang is the name for the rapid expansion of the singularity. As the universe got bigger, it also got cooler. This process of cooling down made it possible for particles and energy to interact, which led to the formation of the basic building blocks of matter. In the early stages of the universe after the Big Bang, protons, neutrons, and electrons were all mixed together in a superheated primordial soup. As the universe continued to grow and cool, these particles started to join together to form atoms. Hydrogen and helium were the first atoms to form, and they are still the most common elements in the universe. As the universe grew bigger, areas with slightly more matter started to form. These changes in density set the stage for the attraction of matter by gravity. Over time, these areas drew in more matter, which caused gas clouds to form. The first stars were made when the gas in these clouds collapsed because of gravity. The intense heat and pressure inside these stars set off nuclear fusion, which made carbon, oxygen, and iron, which are heavier elements. When these early stars reached the end of their lives, they exploded in powerful supernovas, sending their rich contents back into space. Together with the leftover pieces of stars, these enriched materials made up the raw materials for the next generation of stars and the formation of galaxies. The universe's galaxies, stars, and other structures came together slowly over billions of years. Gravity was a big part of how the universe came to be. It pulled things together to make bigger and bigger structures. Galaxies, which are made up of billions to trillions of stars, came together in groups called clusters and superclusters. These groups were linked by huge strings of dark matter. What happened before the Big Bang? Numerous hypotheses have been proposed by researchers in an effort to shed light on the unexplained events that took place prior to the Big Bang. However, these theories continue to throw into question our current conceptions of how the universe came into existence. These proposed theories provide intriguing possibilities for what might have occurred prior to the explosive expansion that marked the beginning of our journey through the cosmos. These possibilities are provided by the Big Bang theory. The Big Bounce hypothesis has garnered a lot of attention in recent years. This theory proposes that the universe goes through a series of cycles, each of which consists of a previous universe collapsing into a singularity and then rebounding to start a new cycle of expansion. This unending cycle of contraction and expansion might have occurred an infinite number of times before the universe we see today came into existence. The ekpyrotic scenario is another theory that proposes that the collision of two branes, which are thin objects that exist in multiple dimensions, was the cause of the creation of our universe. These branes live in a higher dimensional space, and the collision between them kicked off a particularly rapid phase of the expansion of the universe. The initial conditions of the universe were made more uniform during this inflationary period, which paved the way for the assembly of galaxies, stars, and other structures. The pre-Big Bang scenario postulates that the universe transitioned from a state that was low in energy and had a high degree of curvature to a state that was high in energy and had a low degree of curvature. During this stage of the transition, there was a period of superinflation. It was during this time that quantum fluctuations were amplified and transformed into the seeds that would later determine the structure and properties of the universe as we know it today. It is essential to keep in mind that these theories are not incompatible with one another and may even, in some respects, be compatible or complementary to one another. They may provide potential insights into the nature of the universe that existed prior to the Big Bang, addressing questions regarding its origin, initial conditions, and the forces that were at play. Although it is difficult to directly observe and collect evidence for events that took place before the Big Bang, these proposed explanations open up avenues for the theoretical exploration and scientific investigation of the topic. In the hopes of gaining a more in-depth comprehension of the mysterious time period that preceded the birth of our universe, scientists hope to gain a deeper understanding of the laws of physics, conduct experiments, and refine their models. It is still an active area of research in cosmology to try to figure out what happened before the Big Bang, and it is hoped that future investigations and discoveries will shed some light on this fascinating period in the history of our universe. The earliest proto-galaxy cluster. The James Webb Space Telescope has reached a significant new benchmark by discovering the earliest proto-galaxy cluster that has ever been spotted in observational history. This groundbreaking discovery was made only 650 million years after the Big Bang, and it sheds light on the hierarchical development of the universe in a way that was not previously possible. Proto-galaxy clusters are the forerunners of the galaxy clusters that are observed in the universe at the present time. They are the first stages in the process of the formation of cosmic structure, and they involve the coming together of galaxies as a result of the force of gravity to form clusters. Scientists can gain a deeper understanding of how galaxies evolve and interact over billions of years by examining these ancient proto-galaxy clusters, which have been around for a very long time. The discovery of this prehistoric proto-galaxy cluster by the JWST elucidates an essential part of the overall mystery of the cosmos. Astronomers are able to get a glimpse into the past thanks to this observation, which allows them to see the universe when it was much younger and just starting to take shape. An extraordinary opportunity to investigate the processes that led to the formation of large-scale structures in the early universe has presented itself as a result of the discovery of a cluster that was made only 650 million years after the Big Bang. This discovery provides further evidence that the universe evolved in a hierarchical fashion. It demonstrates how matter gradually clumped together under the influence of gravity, eventually giving rise to the complex network of galaxy clusters and superclusters that we observe today. This was eventually what led to the formation of the universe as we know it today. For a complete understanding of the large-scale structure of the universe and how it developed over cosmic timescales, it is essential to have a solid grasp of the hierarchical growth. The advanced capabilities and sensitivity of the JWST have made it possible for it to detect this proto-galaxy cluster. This has provided astronomers with a glimpse of the universe when it was still in its infancy. This discovery not only broadens our understanding of the early history of the universe, but it also highlights the significant contributions that the James Webb Space Telescope is poised to make in the process of elucidating the mysteries of the cosmos. As the JWST continues its exploration of deep space, it has the potential to discover even more extraordinary cosmic phenomena and to uncover even more information regarding the beginnings and development of the universe. The observations that were made by the telescope will undoubtedly cause a shift in our perspective of the universe and open up new lines of inquiry within the scientific community. Previous beliefs about the birth and evolution. JWST have brought about a significant paradigm shift in our understanding of how galaxies are born and how they develop over time. These groundbreaking findings challenge previous beliefs because the galaxies that were detected are unexpectedly larger and more massive than anticipated. This prompts a re-evaluation of our current understanding of the formation and development of galaxies. Scientists have traditionally held the belief that galaxies originated from relatively small clouds of stars and dust that gradually grew larger over long periods of time. However, the observations made by the JWST have overturned this commonly held belief by uncovering galaxies that contradict 99% of the currently available models of early galaxies. The newly discovered galaxies are noticeably larger and more massive than was thought to be possible at their respective points in the history of the universe. The discovery of these unusually massive galaxies at such early times in the history of the universe raises fascinating questions about the mechanisms that are responsible for their formation and growth. It forces astronomers to reevaluate the theoretical frameworks and models they have developed for the evolution of galaxies, which pushes the limits of what we know about this area of study. In addition, as a result of the unexpected nature of these findings, researchers have been forced to consider a variety of alternative scenarios and mechanisms for the formation of galaxies. The observed galaxies may point to the existence of supermassive black holes that are hidden from view, and these holes may have been a significant factor in the formation of the galaxy's characteristics. Alternately, the massive star formation rates that have been observed in these galaxies suggest that radiation from bright young stars may have been the primary driving force that resulted in the end of the dark ages in the universe. We hope you've enjoyed the video. Thank you for tuning in, and we'll see you again soon. Don't forget to subscribe for more videos like this.